This is the third video in Unit 5, and we're going to talk about some trig identities. Throughout our trig units, we will be dealing with several identities, but let's talk about these early ones that you will be having to commit to memory. But the nice thing is they're easy to derive. The first ones we've already really talked about. They're the reciprocal identities. And we talked about which functions are reciprocals of which. So sine theta and cosecant theta are reciprocal functions. So sine theta, the ratio when I take the sine of an angle, equals 1 over cosecant theta, the ratio when I take a cosecant of an angle. And so it goes the other way too. Cosecant of theta is 1 over sine theta. And what's others that go together? Cosine theta is 1 over secant theta. And secant theta then is 1 over cosine theta. And finally, tangent is 1 over cotangent, or cotangent is 1 over tangent of an angle. Okay, so reciprocal identities is one grouping. Next up is the quotient identities. And there are two of these. The first one is tangent of an angle equals sine of an angle over cosine of an angle. And it's pretty easy to see this. One, we really saw it in the unit circle. Remember when we talked about in the unit circle, if we've got this point x, y, and r is 1, and we said in the unit circle, if r is 1, x is just cosine of theta, and y is sine of theta. So y over x being tangent, well, that's just sine over cosine. But if r isn't 1, it still will be sine over cosine, because if we think about plugging in what sine theta is in terms of its definition, it's y over r divided by cosine is x over r. And when we multiply fractions, when we divide fractions, we multiply by the reciprocal. So r over x, the r's cancel, we get y over x, which is tangent. Well, if that's true, then given tangent and cotangent are reciprocal functions, cotangent of theta is the reciprocal of that. It's cosine theta over sine theta. Those are the quotient identities. And the last grouping here is the Pythagorean identities. So the Pythagorean identities. And all of these can be derived from the relationship between x, y, and r. We know that Pythagorean relationship is x squared plus y squared equals r squared. So to get the three Pythagorean identities, for each one, we're dividing by one of the terms. So for the first one, if we divide both sides by r squared, let's do that. So x squared plus y squared equals r squared. If I divide both sides by r squared, well, on the right side, I'm getting 1. And on the left side, I'm going to get x squared over r squared, which I'm going to write like this, plus y squared over r squared, which again, I'm going to write like this here. Well, now let's plug in what these are definitions of in terms of the trig functions. X over r is cosine, so I'm going to say cosine squared theta. Y over r is sine, plus sine squared theta equals 1. That will be Pythagorean identity number 1. Number 2, let's divide both sides by x squared. So dividing both by x squared. On the right, I get r over x all squared. And on the left, I get 1 plus y over x squared. Well, y over x is tangent. So plus tangent of an angle all squared equals r over x is secant. Excuse me. Pythagorean identity number 2. And finally, excuse me, the third one, the final thing that we have to divide everything by is y squared. So dividing both sides by y squared, I'm going to get x over y all squared plus 1 equals r over y squared. X over y is cotangent. So cotangent squared theta plus 1 equals r over y is cosecant. So that is our final Pythagorean identity. And sometimes we're going to find, especially as we continue to add different identities, that, that we can use these identities to make something simpler. And in some case, we'll be using these identities to solve trig equations. Okay, so let's do, what if I said something like this? Let's do an example using these identities. Okay, so what about if I were to say simplify to a single trig function? The following: secant theta minus tan theta sine theta. So one thing I would say, so one type of problem that we'll do is simplifying. And then we'll talk about when we have to verify an identity. So to simplify, sometimes you're going to learn all different types of strategy, but one common strategy is, well, let's just write everything in terms of sine and cosine. So let's try that strategy here. So again, writing everything in terms of sine and cosine and see if we can do anything. So secant of theta is 1 over cosine theta by the reciprocal identity. Tangent by the quotient identity is sine over cosine. And then I've got times sine theta. Okay, so this is 1 over cosine theta minus sine theta times sine theta, which we know we can write as sine squared theta over cosine theta. All right, I notice I've got a common denominator here, so I'm going to write it over cosine theta. And on the numerator, I have 1 minus sine squared theta. So whenever you see a trig function squared, I want you to think Pythagorean identity. And I know that the Pythagorean identity involving sine is cosine squared theta plus sine squared theta equals 1. So if I have 1 minus sine squared theta, and let's think about just rewriting this identity, well, cosine squared theta is 1 minus sine squared theta, according to this identity. So I can replace 1 minus sine squared theta with cosine squared theta, and cosine squared theta over cosine theta is just going to be, one of the cosines is going to cancel, so cosine theta. So pretty neat. Like, again, one good strategy is change things in terms of sine and cosine. Okay, so let's then do a problem that actually was in your packet, a verifying problem. So and again, this is using identities. So what if I said verify, or I could say show that, verify that sine theta plus cosine theta squared equals 1 plus 2 sine theta cosine theta. So one thing you can do, so when you're verifying, first of all, we're going to be sophisticated about it, and we're going to verify that something is true by using other identities that we know. We are not going to change our trig functions to the definitions in terms of x, y, and r. We're going to use other previously established identities to verify that something is true. Because we need to verify it's true, we can't act as if it's already true. In other words, we can't work with both sides together as if it already is a true equation. We either have to work with one side and make it look like the other side, or we have to work with both sides independently and bring them to the same place. So to make sure that I obey that, I usually draw a line around the equal sign to remind myself, only work with one side, or if I'm going to work with both, I have to work with them independently. I'm not assuming it's true. So I'm only going to work with one side and bring it to equal the other side. And often if you're doing that, you want to look at, well, what's the side I can do anything with, or what looks more complicated? And then looking at this, I'm going to look at the left and say, well, I at least can FOIL this out. Sine theta plus cosine theta squared. So let's do that. So foiling it out, I've got sine squared theta. The two middle terms are going to be sine theta, cosine theta, but we're going to have two of them. So plus 2 sine theta, cosine theta, plus cosine squared theta. And rearranging this, because I'm noticing I've got this sine squared theta and cosine squared theta. So sine squared theta, and you don't have to rearrange it and do this extra step, but I'm just doing it to show you. So sine squared theta plus cosine squared theta, well, according to the Pythagorean identity that we worked with in the previous problem, that just equals 1. So this is 1 plus 2 sine theta cosine theta, which is exactly what we have on the right side. Now, when you're doing these, you don't have to do a reason for each step. You're going to assume that your reader, which is going to be me, or maybe in some cases your peers, is knowledgeable of the trig identities. So you don't have to say by this identity, by that identity. But you do have to not skip steps. You have to not make a leap just because you know what it has to eventually you want it to look like. So make sure that you can show me enough that you know how it gets there. Okay. Just run around. I always feel like I have to remind people of that but sometimes they get desperate. Okay, so that was some examples of those using some identities to solve problems. The last type of identity that we touched on was in 5.3, and that was after we solved a triangle. Let me make a new page here. So after we solved a triangle, so let me just do a simple one here. Say I have, and maybe I'll do the one that we did in class. We noticed that, and let's A, BC. We saw a bunch of things. So when we found that sine of A, we said was 28 over 53. Well, interestingly, but when we really think about it, it's not that surprising. It is equal to cosine of B. And we also found that sine of B, 45/53, is equal to the cosine of A, which was also equal to 45/53. Then we also noticed that, I didn't ask you to do, that's true, I didn't ask you to do tangent of cotangent, but we would have noticed something related with tangent and cotangent. But if I look at these angles, if I call this angle theta, then because I know the angles inside a triangle have to add up to 180, and I already got my 90-degree angle, then this angle here has to be 90 minus theta. So given that, and given what we saw in this problem here, we can get at our cofunction identities, which is that sine of an angle is the same as cosine of 90 minus an angle. So these, again, I apologize, these are the cofunction identities. And more to come on this. We didn't do too much on this. We'll be utilizing these a little bit more later, and similarly, I could go the other way. I could say cosine of theta equals sine 90 minus theta. And you could also substitute this, by the way, with radians, pi over 2 minus theta. Then we've got, if that's the case, then it must also be true that cosecant of theta equals secant 90 minus theta. And secant theta equals cosecant 90 minus theta. The final grouping of cofunction identities are tangent and cotangent. So tangent of an angle equals cotangent of 90 minus an angle, and cotangent of an angle equals tangent of 90 minus an angle. All right, and again, there's not much we've done with this so far. Like one example we did is write a function in terms of its cofunctions. So if I said sine of 12 degrees, you could say this equals Sorry, my children are very loud. This equals cosine of 90 minus 12 or cosine of 78 degrees. And so you could replace a function with its cofunction if you wanted to. Again, more to come on this. Okay, so that's it with identities for now.